Welcome to a brief video presentation of two of Fancort's most popular universal lead forming and cutting tools. The tools we'll see in this video are the F1B1 in a hand press but can be used in a Fancort air press, and the F1B3A, which is only sold for use in a Fancort air press. Both of these tools are extremely flexible because they process packages one side at a time. This allows the user to process a wide variety of devices into a gull-wing configuration with almost infinite variation in surface mount footprints. These tools are ideal for customers who have production requirements with a high mix and low volume and can be easily reconfigured to different packages and different footprints in less than 10 minutes. The primary difference between these two tools is the ability to vary the foot length, which is dimension X on our drawing. The F1B1 is designed for users who have a consistent foot length in their packages, whereas the F1B3A can produce infinite foot lengths. Let's first look at the F1B1 and the various components, features, and options. The bottom of the tool consists of a lower cutter, a nesting area for an insert, which controls the shoulder dimension, a micrometer to set the standoff height, which is dimension A in our drawing. An adjustable backstop to create a nest for the body of the component, and the minimum shoulder dimension that can be processed by a standard F1B1 is 35 thousandths or 0.875 millimeters, which again is dimension B in our drawing. The insert is a very critical part of the tool and is easily removed for changes in shoulder dimension, radii, or material thickness. It is very easy to change. The backstop, which controls nesting of the body, also has an anti-tilt mechanism that is useful in securing larger parts. The standard F1B1 can hold a package up to 2.5 inches in width and 2.5 inches in length. A larger version is available that can process packages up to 4 inches in length. Another unique feature is the ability for this tool to process devices with the leads brazed on the bottom. In order to handle this type of device, the backstop is replaced with a combed backstop that allows the leads to be properly nested. It is very easy to set the standoff height by unlocking the mandrel that holds the nest, then adjusting the micrometer to the desired height and then relocking. Micrometers are available in inch or metric dimensions, and a digital version is also available. The top of the tool consists of the former and pressure pad, which clamp the leads during forming and cutting. Another feature is the ability to easily change clamping pressure by changing springs. Here is the sample we just processed on the tool. As you can see, we cut and formed one side. A specification sheet is provided for customers to develop the correct dimensions needed for specific applications. We have specification sheets for two-sided and four-sided parts. For packages that have non-conductive tie bars, the tie bars must be removed first before using any universal tool. This can be done with a Fancort F3A adjustable lead cutter or with a sharp scissors, but we don't recommend scissors because of potential stress to the package and circuitry. Now let's look at the F1B3A, which is a more versatile, universal system because the foot length can be infinitely adjusted. This tool will also process one side at a time and consists of a lead cutter for trimming the leads and or removing the tie bars, mounted alongside a lead former. When using Fancort's universal tools, it's essential to have the following. 1. Manufacturer's specifications on your part showing the unformed device if this is available. Or if not available, complete a Fancort specifications form showing all dimensions on the finished part. Number 2, a Fancort worksheet to develop the initial settings for lead length and standoff height, which will determine the correct insert to be used. Number 3, an inexpensive part to test your setup. Sometimes it's necessary to tweak a dimension on the cutter or former, such as standoff height. Number 4, a comparator or similar measuring instrument to inspect the test piece and some or all of your finished parts. Useful accessories from Fancort are 5. A heavy-duty vacuum pen for handling parts. 'HP 100 vacuum pen is supplied with 3 different size tips, depending on which one is needed for the components you are processing. A coplanarity inspection mirror to visually inspect for proper coplanarity. Number 7, a standoff measuring tool, a useful benchtop device for measuring finished standoff height on a formed part. The micrometer reading at the first sign of part motion is verification of the standoff height. Now let's see how we process this 196 lead top exit quad pack with non-conductive tie bars on each side. Because this package has these tie bars, it requires 12 operations to finish a part. 4 operations to remove the tie bars, 4 operations to cut the leads to length, and 4 operations to form the leads. If a quad pack doesn't have non-conductive tie bars, the processing requires only 8 operations. Two-sided packages require only 4 operations to produce a finished footprint. The first operation requires removal of the tie bars. The operator adjusts the micrometer backstop so the cut is made as close as possible inside the tie bar, but without touching the tie bar. Then the operator adjusts the backstop to seat the package. Now let's remove all 4 tie bars. Using the worksheet we've previously completed, we proceed to the next step. The next step is to trim the leads to the length on the cutting station. The lead length has been calculated on our worksheet using the formula provided. The length we've developed is 177 thousandths for each side. The last step is to form the leads on each side to complete the footprint. The proper insert has been mounted into the tool that will produce a shoulder dimension of 51 thousandths with a radius of 10 thousandths. We've adjusted the standoff micrometer to 105 thousandths to achieve a standoff height of 10 thousandths, and then adjusted the backstop to fit the body of the part. We then carefully position the hold-down spring over the trailing edge of the part. Now we're ready to complete the process by forming the leads one side at a time. The finished test package should now be measured on an instrument such as an optical comparator to determine the overall lead length, foot length, and standoff height. The system we see here has an optional plastic sliding shield with an interlock. The customer for this unit requested this option. However, Fancort feels it is unnecessary because the operator uses two-hand safety controls. That completes this brief video of two universal lead forming and cutting systems. Fancort also offers the Flex tool, a universal system that processes two sides of a package at one time and is available with automatic standoff height control, a unique Fancort patented system.